Have you struggled with tear-outs when trying to make precision cuts? I've tried lots of different things to combat this, but only one's provided me with consistent results. In this video, I'm going to show you just how easy it is to make a zero clearance throat plate. Don't have all those fancy tools? No problem. I'll provide you with alternative ways to complete each step. At the end of this video, I'll reveal an even bigger reason why you should be using zero clearance throat plates. The reason a tear-out occurs is because there's a lack of support for the wood fibers as the blade comes through the wood. I've tried using tape and cutting through it, and while that does improve the cut, you have to use tape, which adds time and cost to your project. Not to mention, you have to remove the tape from your finished piece. The other alternative is to use a sacrificial board under your cut. The challenge with this is that you're sacrificing wood. Alternatively, a zero clearance throat plate gives your piece the support it needs and doesn't require all of those extra steps. Let's dig in and start with the first step. It's pretty easy. You have to remove the existing plate. There's different ways they may be held on. As you can see in the example here for my miter saw, I've got 6 screws to remove. But here on my table saw, I've got 1 screw in the front to remove, and then the plate just slides out and up. Now that we've got the templates out, it's time to rough cut the blanks. Find a piece of wood that's just slightly larger than your old plates. I recommend using hardwood. And then just trim it down to be about 1/8 inch bigger than the original plate. You'll trim this to an exact size in a later step. Now we're going to rough cut the thickness of the plate. There are 3 ways that you can do this. My preferred method is to use a bandsaw, and I resaw the board to the desired thickness. If you don't have a bandsaw like this where you can resaw, you could use a thickness planer. One challenge with the thickness planer though is that you could wind up with snipe on the ends of the board. So if you're going to use a thickness planer, I recommend you start with a longer board so you can trim off the snipe once you achieve your final thickness. And then a third option is to just use your table saw. You can cut the board on one side, then flip the board over and cut it on the other side. Now don't try and cut halfway through in one pass. There's a chance you could burn the wood, or the wood might bind up on the blade. As you can see here, I'm taking several passes at the cut, and I raise the blade a little bit more each time. No matter which method you choose, you want to cut the board to be about 1/32 of an inch thicker than you need it. This is going to give you that extra thickness so you can sand out any imperfections or marks left by the saw blade. Now you need to trim the board to its final fit. My preferred method here is to use a flush trim bit in my router. Using some double stick tape, I just adhere the original plate to the wood, and then the roller on the flush trim bit guides us to a perfect match. If you don't have this set up, you can trace the original template onto your wood with a pencil. And then just by using a disc sander or a belt sander, you can sand down to the pencil mark. You might have to do a little trial and error to get the exact fit, but you can still achieve the same results doing it in this manner. Now you're going to want to sand to your final thickness. Depending on how much material you need to remove, you may need to be more aggressive with the sanding grit and work your way up to a finer grit. Periodically, I recommend you test your fit. Remember, you can always remove more wood, but you can't put it back on. Now it's time for you to drill the holes for mounting the new plate to your saw. Start by taping your original plate to the blank, and then use some sort of a centering punch or a scratch awl to mark the very center of the holes that you're going to have to drill. Once you have the holes marked, you can remove the original plate. There may be a couple of drilling techniques you need to utilize here depending on the type of plate that you're replacing. As you can see here for my miter saw, I had countersunk panhead screws that hold the plate to the saw. So in order to make these holes, I need to either use a Forstner bit or a brad point bit and just drill part way through. Once that's done, then I drill a smaller hole through the center of the first hole. If you don't have a drill press, no worries. You can do this by hand or just get one of these little drill guides that you see here. Just be careful not to drill all the way through with the first bit if you have this panhead situation that I have. For the table saw plate, it's held in with a flathead machine screw, so you just have to drill a countersunk screw hole and make sure it's deep enough to allow the head to sit flush with the top of the plate. Before doing your final install, I'd recommend just applying a coat of shellac or some similar finish. It just helps protect the wood from any moisture you might have in your shop, and it makes it look a heck of a lot nicer too. Now that the new plates are installed, it's time to make our virgin cuts. So here you can see me doing this with the miter saw and then doing a test cut to see how clean the cut is. On the table saw, I recommend you move the fence over the edge of the plate. This will provide extra support since you're going to be raising the blade up from underneath and putting upwards pressure as you do so. Then make your test cut and admire how clean that cut is. In the beginning of this video, I mentioned an even more important reason for using zero clearance plates. It comes down to your safety. As you can see here with the miter saw, I'm making thin cuts and the piece that I'm cutting off falls through the plate. As these cutoffs build up, the blade might grab one of those and throw it out of the slot, causing a dangerous situation. It's even worse on the table saw. As you can see here, because of the amount of space between the original plate and the blade, there's a chance that a thin cutoff could fall through. If it falls behind or a tooth catches it, a kickback could occur and hit you. I've had this happen to me. It's not fun. Actually, it hurt a whole lot. So there you have it. Zero clearance plates for better quality precision cutting and your safety. I recommend you put these on any of your power tools with circular blades like your miter saws and your table saws. I hope you enjoyed this video and found it helpful. If so, I'd really appreciate you giving me a thumbs up and subscribing to my channel. Thanks for watching.